still rolling or something like that. And so it's called an outtake.
Okay, that could be interesting. Yeah, that takes it to acting versus persuasion, and acting is a kind of persuasion.
You
But
know,
acting also has all these director calls, like your character is this. So I want what I was act. So the thing with acting for me is that it's not the real person who's. It's not a natural act of like it's me trying to portray a character rather than me trying to convince you of a point naturally. Like how I would naturally try to convince you of a point versus me conversing with you without trying to convince you of a point. So acting.
How about reporting scientific facts without trying to persuade people, like in as a neutral way as possible, maybe
Interesting.
explaining a mathematical equation, like you're not trying to persuade anybody, it is what it is, so it's how you take
That's fair. Maybe
the
what I can
derivative
do
or
is
whatever.
look at news channel reporters who are just reporting versus news channel reporters when they're in a debate.
Right.
That could be good, I guess, for this. Yeah. Thanks.
So,
So okay, so that's Nippon, and so uh Laura, can you tell us, you're the next in my screen.
No problem. So I'm looking at virtual versus in-person conversations and how we might change facial expressions. And I had some like questions, I guess, about it because I started collecting data. I have the virtual session, and actually I mostly only have like staged expressions from my other two participants, but I'm thinking about the narrative, and do we want it to be like exactly the same both times? Because I feel like that would bias at least one of the, you know, experiences, I guess. Does that make sense what I'm asking?
yeah, because they're fundamentally different, right?
Right. Yeah. So I had them just tell me a story about like something had happened to one of my friends and she was just telling us about it. And it sort of did span the range between like we were angry, we were sad a little bit, we were also laughing at some points. So I was like, oh, this kind of captures like a lot of the, different emotions potentially that we might be interested in. But then, I feel like if we do the same thing in person, does she just need to repeat the story? She can paraphrase it or change the wording slightly, or do I need to have her just like read something? You know what I mean?
um Tricky because you're trying to compare these two things, right? So
Right. Yeah.
it makes sense that all things being equal, if they're different, they're different, right?
Yeah.
Because if they're different, then they're different because somebody could argue they're different because they're different narratives, right?
Yeah. Well, right. I mean, so I could have her sort of like go through the same conversation, just repeat the story again, but it won't be like rather than her having it be word for word the same. Like, you know what I mean? Will it matter at that level?
No, I think the level of spontaneity is good because
Yeah.
if you make it too scripted, then that could have an influence in trying to retrieve from memory the exact script that may confound the whole thing.
Yeah, right. I know.
So
I also got their staged emotions too, so we could compare, you know what I mean? If it does like seem like it's a little further closer to like a fake kind of thing, we could maybe kind of tell that, but okay. But yeah, so I haven't done the in-person yet. Obviously, we're going to do that this weekend, hopefully. But other than that, I'm pretty close to done.
okay. So, I mean, again, for both you and Nippon that are processing, bring it to the stage where you can, crop the faces and all of that so that it's easy to process with open post. You guys have open post? No, Nippon does.
Okay.
No? Okay. So yeah, bring it to the crop. Since you're doing also two people, in your case, Lara,
Yeah.
make sure when you use what is it called? Gosh, the cutting thing.
Clidio?
Clidio?
The
Clidio.
Yeah.
When you use Clidio, make sure to follow the order I suggested, which is first cut
Yeah.
and then crop.
Yeah.
And that
So
way
I-
it'll be synchronous.
Yeah, so I didn't cut the narrative at all yet, but the stage videos, I did not follow those instructions. I did the cutting before I read that document. So I'll have to go back and redo that, but
Yeah, so do the cutting first.
Yeah.
And then, so for example, in Kaylee and Jay-Way's video, Kaylee was doing like 1, 2, 3, go. And then the video starts, right?
Yeah.
So I had to cut that part. So I cut it from when they're together. So because the way that she so let me just second show you the example. The way that they recorded it. So let me share the screen. Yeah. So this is like you see my screen?
yeah.
So these are all the Matlab files I run, like I just ran them while I was doing other things.
Mhm.
But so the first thing is they gave me things like this, for
Mhm.
example, right? So they're that simultaneously there, right? So I had
Yeah.
to, this is already cut in the way that Kaylee's already done the 1, 2, 3 thing.
Mhm.
Then I had to bring that to Clidio and crop it.
Mhm.
So happy no language. So happy no language is this one here.
Mhm.
So this is Jay-Way and this is Kaylee. So then I cropped it that way. And also make sure, like in Jay-Way, in some cases, see how the neck here is not, so make sure you try to do it so that it's more like this,
Okay. Yeah.
where you see the shoulders. So it's
Okay.
a little bit, try to do it like that. It's easier in all for open poses also. I'm also, because in some cases, for example, in their case, I'm also saving the audio of extracting the audio that Joe taught me how to do that in using these
It was
what
just
is it?
Premiere. I taught her.
Premiere, yeah. So so this is the audio here,
Right.
and so I can play it and then I can load it and process it using the MIR toolbox in MATLAB.
Mhm. Yeah, I've been using Zoom so that like you
Yeah,
said-
Zoom saves the audio separately, so that's nice.
Yeah, easy enough.
Yeah.
Okay.
Okay, so let's try to do that so that we get the data ready. Any questions there, Laura, or you're clear on?
No, yeah, I think I'm good. I'm just gonna have her I'll rewatch the narrative and then have her go through it, sort of like,
Okay.
the major goalposts, but maybe not exactly the same, and we can see what that looks like. And then, they're open to continuing to participate. So if we find that we want to do like an exact same narrative, we can do that too. It's fine.
Yeah. So I mean, actually, if you have like if you do it like with a scripting,
Mm-hmm.
that might even reveal the differences.
Okay.
Like forcing the person to do it scripted by the script
Yeah. That's good.
versus because that would be like, memory would then be a problem there. Like you have to recall the exact thing versus spontaneously, you just give like the overall
Mm-hmm.
topic and the person goes.
Yeah.
And that should give you, even though you may have the same range of emotions in both cases, we may see differences when you have to recall because
Yeah.
you're truly staging the thing.
Yeah. Okay. That's fine. I can do that too then.
So, okay, now Richa, you go next in my screen. Although I tell you, Zoom shuffles, right? So Nipun is now down here. And
Nipun is on the right of Rich and mine It's all over the place.
Yeah, it's all over the place. So
Supposedly it rotates.
and they
in a-
they
it should
shuffle.
be
So
like
I'm talking to
a
somebody
virtual-
and suddenly it jumps the other way.
It should be on a circle, on a virtual circle, normally, to
I think
simulate.
it depends on who's talking.
Yeah, but
Like who's talked the most, I feel like is
I
what
think
jumps
it's
up.
something you can actually set up in some settings or something. So it's like a virtual room. That's what it should be.
So Richa, you're doing the aging actors, right?
Yeah, so I haven't extracted the videos even yet. I have to download them from YouTube, but I found clips, but only about like 15 to 20 seconds that are just the face of interviews. So far, I've just done Will Smith, but of interviews from when he was like very young and then like Fresh Prince of Bel-Air aged and then now. And then I found clips from movies also of just his faces of him being sad and happy. And I have to just extract the videos and run it through OpenPost still.
Okay, so do that and then we can create these narratives. I'll go today again over the code I posted on Box. And all you would have to do is, for this particular code, change the name of the file and run it with your file. But we should play with it to, define different regions and things like we can track all 69 points instead of the 3 points instead of the summary 3 regions that I did. That's also possible, and then you could see more stuff there. So that's also a modification we can do to the code. Okay, so Kaylee, I have your stuff. Of course, I have to rerun it with a new file that is now corrected. But it's all the hard work is done. So it's like easy now to, and it's all in Box. Do you have a PC? You said you didn't?
I have a PC, but it doesn't handle the software.
Because it doesn't have the GPU.
Yeah.
And J-Way?
I think he might have had the same issue, except I think he has a Mac, but I'm not entirely sure.
Okay, because it's a few videos I had to run. I mean, I just set it running in the background, so I'll just redo it. But yeah, because it's quite a few to do that. All right, then Elizabeth, you said you were.
Yeah, so my daughter, I've gotten 2 of hers cropped and up to the box, but I realized that when you were showing Kaylee's, that she didn't use the blue background, and I don't know if that matters. I think I can go into Adobe Premiere and add it, but I'm not positive. So, but I definitely have 2 of hers up on the box where I already cropped them to where it's just her head, basically.
And did you do it in Zoom or did you do it?
She did it in Zoom, but I didn't give her the blue background.
Well, I think it's okay. But Zoom also, so can you upload the audio file that Zoom gives?
She muted it. She didn't do an audio file on it. Did you need an audio file?
No, but it would be.
She didn't do a narrative or anything. She just did the facial expressions as faking it, like as an actor, and then the facial expressions based on something she was watching.
Okay. So she has no speech or anything.
No. So she.
Okay. I thought that you were gonna. I thought she was gonna do like some kind of acting with like full blast.
I could get her to do it. I could give her a script if you want me to do that. But I thought she was just doing the facial expressions real and the facial expressions fake.
Yeah, we can do this from her since she's an actor. But if you want to do the Zoom thing with acting something like with voice and everything, that would be also nice.
Okay, I'll talk to her because she did these really fast. She's good on Zoom and stuff like that. So I'll get her to do it again. And so and my husband and my son haven't done theirs yet. Do you want them to read a script and say something, or just make the facial expressions?
Yeah, I don't know. Maybe, yeah, the facial expressions, just the facial expressions is fine.
Okay.
And let's see what comes out of that. I mean, it's all very exploratory, right? So,
right.
What we're gonna get?
I know I can get her to do the narrative really easy because she just,
yeah,
she'll do it. My husband might give me a little pushback on it. and my son is in the middle of his own finals week, so
yeah, so we don't want to push it. Okay. That's fine. So I'll have a look at the stuff you have in box.
Okay.
To create the Matlab files.
Right. I'll finish getting hers in today. And then because I've got two of hers, I've got the real happiness and the fake happiness, but I'm having to go in and crop hers so that they're not too big. And then Joe is going to get the open pose installed on my machine tomorrow. So I can process the rest of them this weekend. And then once I process them through open pose, then I just take them into MATLAB and use the file that you already had, right?
Yeah, I prefer you do it so that you see how it's done open pose, because particularly for your research, you're going to be using this tool.
Absolutely.
A lot. So it will get you. And if you get stuck or anything, just send me email. And okay. I've done so many of these now. By now, it's easy.
Okay. So then I'll get them all done and processed by Sunday night, unless I have some kind of malfunctioning problem.
Yeah. Great. Theo, your circadian rhythm thing.
Yeah, basically it's circadian rhythm, but it's related to activity. So the way I give the instructions to participants, and that far I have videos from one participant, is that each one short recording right upon waking up, one after having breakfast, one just before lunch when they start to feel hungry, then one after lunch. So it focuses on the various activities, because someone may be moody if he's hungry, for example. I know I am. And like during the day, a couple more random recordings, and then before or after dinner, and then right before sleep. So it pretty much spans the entire part of the circadian rhythm when someone is awake. And I also ask the participants to declare for each recording what their activity is at that moment and what their mood is, to characterize their mood. Like, I was thinking of making like a questionnaire that, do you feel happy from 1 to 3? But then I said this is too restrictive. I don't like this kind of questionnaires. They're too restrictive. What does it mean to be 6 out of 10? Agree, disagree, not sure. I mean, when you let them like express the most, much better. So I have one participant. Hopefully I'll have one or two more, but I can process already one, because the whole point is the cycle is not the
process that one to see the pipeline and see what you get, and then you can do the others if you know.
I suppose there should be some differences throughout the day.
I'm
pretty sure about that.
I think so. And the whole point, one of the whole points of this paper is that even though these are universal micro expressions that we start out with, there are all these variations in the facial expressions that we can characterize as a trajectory.
Yeah, and the higher order like structures that you study, the more different you will find. I mean, some may be obvious, like when someone wakes up or is very tired, it's obvious that even his muscles are tired. But even like between different activities, between 4 or 7 o'clock, maybe something changes. I don't know.
Yeah.
Something's like,
I wonder, I mean, this is going to be a small n and we won't be able to say anything, but I wonder in general, like how different people that are like nocturnal versus, you know,
yeah,
day
yeah,
baboons versus night baboons, you know,
or hybrids.
people
Some people are both.
like they like work, they have a lot of energy working at night, how they differ from people who have a lot of energy in the morning.
I think one part that has to do with this, but this is anecdotal, this is like from observing myself, is how you respond to light.
Yeah.
Because light is a switch. So I don't know. It's because someone could be productive late at night or early in the morning because of the same reason, that there is there is not much light or much activity to distract them. So yeah.
Okay. Melissa, you already told us that you have the videos, right? You cropped them.
Yeah, so I'm almost done cropping and I have to cut them as well. But I'm almost done. I have a couple, but I just need to upload them.
Yeah, so remember, well, you're not doing anything.
Yeah, I'm not like comparing, like I feel like the order probably shouldn't matter.
In your case, doesn't, because it's just one person and all you're doing is, okay. Yeah. All right. I think that's that. What else? Yeah, so now I'm gonna go over so Joe, that's it. If you want to, if you're busy, if you want to stay, great. If you're busy, don't worry. I just want you to see all the projects we're doing.
Okay. I mean, I can stay until the end. Just I'll be like on mute if you need me.
Okay, yeah. So one thing we did, Joe, from the beginning was we took these Vanessa Van Edwards videos, right? The universal micro expressions, and we collected data on those V1, V2, V3, and created like a gamma plot of the triangle of her face for each one of the 7 micro expressions.
Mm-hmm.
So we got that. And then I took her narrative saying something in a YouTube channel she created, and then localized, build the trajectory in gamma space and localize each point of the trajectory relative to the 7 anchors of the micro expressions of the 7 universal micro expressions. So we did that. So that's what I'm going to go over in the code that I put on Box. So let me share the screen. Okay, hold on a second. Let me. So before I do that, I kind of probably want to do the phase data. Just a second. Okay, yeah, so let me share the screen. Before I go over the code I put in Box, I wanted to show you the MIR demos. So MIR is this toolbox for music analysis, for audio analysis. And you know how Zoom has this audio only file? Oh wait, let me share with the audio thing. Hold on. Share and share computer sound. So maybe this is not it. Okay, so I can so I can run a number of functions from the MIR toolbox. You have to install it and then put it in the path of your Matlab, set the path pointed to that and all the functions that it has. And this is a set of functions. Let me see. So you can set the path this way, or you can just manually go into the where is it and here and set the path in MATLAB, and then you point set this thing to point to the folder you want, right? So you would have to go to the MIR folder, and the toolbox is called MIR toolbox. Let me see if I can find it online for you. Yeah, so this is it. You can download it, and it has, it's out of date. So you can go to their actual toolbox at their university. So it has several other toolboxes, but you want this one, the MIR, and so it has great documentation, so you can learn about so it has the user guide, a primer about the toolbox, and some articles, some video tutorial. I have downloaded this, and so it's great. You can it gives you about installation and so on, but the basic sets up the basic functions and explains the basic functions to the basic operators that you can do on the audio file, and then you can plot a lot of different and extract a lot of different features of the sound, dynamics features, rhythm, timbre, and all that, pitch, tonality. Each one of them will give you like waveforms that you can then analyze and combine with a phase, with a waveform that you create from the phase. So so I recommend it. These are some of the examples of how to do this analysis. Actually, this code was written by G. Let me run it. She used it, so let me just run this. And this is just from an audio, the audio file that Zoom creates. It's a .wav file. You want a .wav. And then this does some basic analysis of the data and plots. In this case, takes the envelope and plots 10 of the filters that they use. And so that you create a waveform for each one of the filters. And then here you can do a lot of things. So like find the peaks, and she takes the what is called the attacks and the slopes, the attacks and the release, whatever it's called, for each one of these 10 envelopes. So, and then plots the attack envelope for each one of them, or each one of the filters. This computes some area between the minima and maxima. And these are arbitrary things that, and then this plots the areas. So these are the areas then plotted to this, the sort of along the time series. Not time series, it's time series, but you have to do a conversion here on what this means. So that's one example. And then I wrote this demo function, which then converts the audio, and then you can plot some of the. And I got an itch on my head. Oh yeah, so this is playing the.
Consent to these. I didn't know that. You have to consent to the video recording.
Oh wait,
Yeah.
no, I'm sorry.
you
So
didn't.
how do I do that? Hold on.
We just press continue. We just press continue and it works.
Yeah.
So now recording again. So this is us fooling around with so this is the whole audio. Jenna's just interrupted there. But essentially then we can extract from like each one of the participants and code the specific, extract each one of them and code the specific segment for them. And the reason I did this is because after we did this breakfast thing, and then I did the network analysis, I included the sound to that end. So this would just play Richa, for example.
I had a banana and yogurt and a bunch of fruit and coffee.
So you can plot the envelope. That's the envelope of that sound. And then apply different flags and different settings to get, this is the halfway rectify envelope. But all of these are then waveforms that you can perform analysis on. Point is that you can then, this is a spectrum, and the spectrum computed with different flags that give you different characteristics, and you can get the peaks of that. And so the autocorrelation of the waveform, there you have the autocorrelation. And so on. So the point is that you can get different, let's see what this does. The flux. You can get different, so this is the spectrum, and this is another waveform, the spectral flux of the audio, and you can get different plots from it. This is actually boxing each one of the segments, so it automatically segments the data. So I encourage you to play with it, because it generates a lot of data that you can then use, and it gives you all the numbers of the time series It's the global energy. So novelty is another measure that you can apply and get these peaks that you can do all the, and then various similarity matrices that you can apply to it to get patterns. This is a chronogram. Okay, so I'll share this in the box. And the point is that with the audio, if you include audio in your analysis, like I plan to include audio in Kaylee's and Jay-Way's, because as I said, for like, say, they're listening to Chinese, and clearly Jay-Way's is both are reacting to it, but clearly you can see the difference in the intensity of the reaction. And so I can correlate the phase reactions with the audio waveform, which I can take a lot of different characteristics from the dynamics, from the pitch, from the timbre, from the, all the characteristics. And we can correlate them and see maybe like what correlates highest, or what is more predictive of what you have as an outcome. So one of the questions that I have is whether we have an analogous thing to the 7 universal microexpressions of the phase in the auditory domain. So these are in the visual domain, or the motor domain rather, for the facial expressions we're doing. So these are micro gestures. So if we recognize it visually or sense it motorically. So I'm wondering if there is anything that maps to the audio when people are listening or talking and saying something. So for example, in Mona's account of this Colorado killer, so Mona is going to be analyzing the data from that guy. What's it called? The Next Door Neighbor. Where is it? Mona, the name of the movie, of the Netflix?
American Murder or something. The guy's name is Chris Watts.
So I don't know if you guys have seen in Netflix, this guy who killed his wife and 2 kids, 2 daughters. It's really...
Is it a series? Is it that has different?
It's only one documentary, right?
Yeah.
So, but it's interesting because I remember watching it, and they were interviewing him on TV, and I remember watching it when it happened. And I remember watching this and telling my husband, he's lying. I could tell he was lying, because his facial expressions just did not correspond to sadness or anything genuine that I could tell.
To everyone, though, I mean, did he have skills to actually successfully, like, you figured out, but would most people be able to figure out that he's deceiving?
I don't know, but I guess because I've studied behavior for so long, I could tell he was lying right away. Because when you're sad, genuinely and desperate, you act differently than this guy was acting at the time. Eventually he confessed. And eventually you can see in Netflix like the progression of the confession, because first he confessed, but he blamed the wife. He said he had to kill her because she had smothered the girls. And then he finally confessed that he killed both the mom and the girls in a horrible manner. But anyhow, Mona is going to extract segments from these, and there was the point where they actually give him a lie detector, and I was hoping to do something with his audio as he's lying, and see the face but of the other person giving the lie detector test, but I guess you can see the face. So Mona was proposing to do the voice of the person. So we could do this because, see, with the audio analysis, we can extract waveforms too, that we can apply the same macro movement thing to it and the cross coherence and everything that we do. This would be also ideal, Theo, for your gang causality techniques.
Yeah.
Analyzing the face, the face and the voice, and or the voice combination. So we could play with that too.
Yeah, and the new one. I mean, the new one is under construction. But
yeah, the new one is under construction. But
yeah,
once we understand it well to adapt it.
Yeah, because
the point is another waveform that we can incorporate. And because the micro movements is standardized, it doesn't matter that this comes from audio and the other one comes from the face. They're standardized, so we can cross-correlate them or cross-coherence them.
I wonder, because we're talking about afferent and efferent nerves and in the face, and that goes back to what we were saying earlier, maybe we could do a little research on where these map on the brain, because this could shed some light on whether the different processes are convoluted with each other. I mean, I'm saying this just to make a model that is physiologically realistic.
Plausible.
Yeah, I don't really know about.
In general, we should find out more about this mapping. Find out more in the literature. So I have this paper that just came out this month in Geo Neuroscience. It's a review on sensory processing. I'll share that with you. So it maps. They managed to map all these tactile afferents. I wonder if they go through so they go through the skin, the hand. But I don't think they go through the face because it's a different system. Yeah, they do to the face. Okay, here it is. Let me share this. And I'll share the paper with you. So, can you see it?
Yep.
Yeah, so this is like the latest review. And they place it all in context of all the sensory processing that we do. And essentially the current estimates are incomplete. So they're trying to complete that. And so glabrous skin is like hairless, by the way. I looked it up because I didn't know where it was. And so they do kind of an examination of different types of fibers, and then map it out very nicely into the different somatosensory areas for the feet and the hand. So scrolling down, they do the face. So what the face, let's see what they do. Highlight essential sensory contribution around 43 to 46,000 tactile, afferent, innervated, hairy facial skin and the lips, excluding the oral cavity, which is likely to be innervated by around 16,000 to 19,000 fibers. So maybe we can find some information about different areas, like the areas that we are trying to get these trigeminal nerves and the muscles for. So I'll read through it, and I'll share the paper see what we learned from it. But in the paper that we're going to write, depending on what journal we target. Like if we were to target the J of Neuroscience, definitely we would have to be heavy on this kind of anatomical stuff and neurophysiological information, which, you know, this is a very nice review, and it's the latest this year. It came out last month. So that should be good. So let me then go over what I have in box, and again share it. So remember that, so this is our folder for the class, right? We have PDFs and documents where I've been putting the PowerPoints for each lecture when we have PowerPoints. We also have lectures, Zooms, and videos where I've been also putting each one of the videos. I'm recording this one, so I'll put that there too. We have the open post that Joe put there for people to upload to their computers for those who have. The phase data has everybody in the class. So for example, Kaylee, and I put in Kaylee's folder all their conditions, SAT Spanish. So we have the WAV file that I extracted with the original file, and then the original video cut, and then the crop videos. And then I have the Matlab files for that. So I'm giving this as an example of what you should be putting in your files, right? So she has all these conditions. They listen to things in Spanish that were sad, no language, in English, in Chinese, and then happy. They did happy as well. So we have all of that. So that is going to be analyzed. So, and then for people who still have to put their stuff, so we have the process video. Remember that with the data from the MATLAB data and the process file for each person. So these are Nippons, for example, with the sample micro movements from each region. And now if you have the 69 files, you can generate these micro movement stuff, but for each one of the 69 of the 70 points. This is the raw speed data for all those. But of course, if you have for each frame, then you would have to have like for a number of frames. So so that's the phase data, has everybody's individual signatures, and it will have then everybody's project. So Kaylee has the signatures, the original for the original 7 universal micro expressions, and she has also all the files for her project for the paper. And we also had the group analysis. Remember that we had for each one, like surprise. So we had for each one, we ended up computing the surprise for those 3 regions and the happiness and so forth. So this was that for everybody. So that is in the phase data file. And then we have the code in MATLAB. We have the code for the air-mover's distance. We have the phase data analysis contains all of the code for a sample analyzing one of these. This is then the narrative, which contains, now that's uploaded that last night, so that contains all the code to run and get the trajectory of the face as somebody is narrating something. So let me go over that. So this is what I put on in box. So let me close everything. And essentially you would have to replace this with your file, the file that you're going to get the narrative from. This particular code is done for the 3 regions, V1, V2, V3, but we could modify it to comprise all 70 points of the face. But remember, if we ran this already, but if you were to run it, so I'll run it and we'll go over. What it does is gives us the trajectory on the gamma moment space. It gives us the trajectory of the narrative and the 7 universal microexpressions anchored, like I use as anchors to measure, then to measure the distances of each point in the trajectory to each one of the anchors. And then I run all this other code to get the PDFs corresponding to each one of the region, V1, V2, and V3. In red here is the trajectory, meaning that each one of these is a frame in the gamma trajectory, comprising half a minute. And then also for V2 and for V3. Now, if you were to do 70 of these, then you would have 70 points with PDFs. And likewise, you would have 70 of these trajectories on the gamma parameter plane. Ignore this for right now. This is the air mover's distance computed from each point in the trajectory here in the gamma moment space to each one of the centroids of the emotion. So you have V1, V2, and V3 for each one of the emotions. So for each one of the points here in the triangle. So for V3, you can then map out the distributions of trajectory points in distance to each one of the emotions. This is for the region V2 and so on. So now you could do it for like the pupils and so on. This is the same color map. I explained this before, where you have the 7 universal microexpressions. And in this particular case, we have like 39 frames. Each one of them is comprised of so many peaks from the micro movements that we extract for half a minute. And these are these are at with 10% overlap and 5-minute intervals. So we can do it for half a minute or depending on the length of your narrative.
Yeah, how long should the narratives be, do you think?
Yeah, so like in this case, I did for 60. So this is frames per second comes out here. It's in this case 23.97 frames per second, and I did a whole minute. So in this case, So, I mean, it will depend on the length of your narrative, but we should, for each project, we should have an agreement, right? Because it should be the same unit time that you chose for the emotions, for the 7 emotions that you're gonna use as anchor. So if you have your 7 emotions for you, right? And you're gonna do this narrative thing, whatever unit time, if you use like 1 minute to build the point on the gamma space for your emotions, then use 1 minute frames with, I'm using 10% overlap.
Okay, yeah, no, that's fine. I'm sure I'll use the same unit as when I do each one, but I was wondering just the narrative in general, like how much data do we need or want? Like, so do we want to need a 20-minute long thing, 10 minutes?
Yeah, I mean, it not too long because it takes computer time. So at your end, it's going to be taking some computer time to take the Matlab from OpenPose to process the OpenPose. And then you have to process this gamma thing.
So less is better.
Yeah, I mean, if you do like 20 minutes, it's fine.
Yeah.
But if you get into like 1 hour, that might be too long.
Okay, no, that's fine. Yeah, I'll do something between 10 and 20 minutes.
Yeah, I think that should be sufficient. And also because one thing that we should do is play with the intervals. So say that you do half minute, 1 minute, 5 minutes, for example.
Yeah.
And how much does that change the conclusions, right? The overall outcome of what you're, if for 5 minutes and for half a minute, they're still separate, for example, and are still visibly separable and quantifiably separable, then we should say that.
Mm-hmm.
But if on the other hand, reducing the resolution, the sample resolution from 1 minute to half a minute makes a big difference, then we should report that so that people know that there's some bound on what we're doing that will change the results.
It makes a difference. Yeah, definitely.
So for reproducibility, so we'll report on that. So this code is in box now. I encourage you to try it and see if it works okay with your, and then play with it so that, as I say, there's the resolution for each frame. So any questions about that? We had gone over this code before in the other class. That's why I didn't go over it in detail, but it creates these graphs and you can do more. This is just like the surface. And what I was thinking is in the next class, I'll show you in detail the network analysis, and then that would be the end of it. For those of you who have dyads, or so in this case, Laura has a dyad and Mona has a dyad and Kaylee and Weiwei have a dyad, and Elizabeth is going to have a dyad too because your husband, your son, right? Theo is alone. And so is Melissa, and so is Nippon, right?
Yeah, there is no diet, but one could think that
you could do something with sound.
Sound is just background laptop videos playing on laptops. It's the subjects don't talk. It's media playing in laptop, but the interaction could be with, for example, the video before eating with the one after eating. What is the relation? But this is not a. This is more like a diet to the future expressions that they like. How does the state earlier affects the state now? Like a chain. a chain.
Well, in your case, you can do those Granger
Yeah.
lagged analysis. So yeah.
Yeah, something like this. Or...
And you could take the same subject and do pairwise analysis across the day to see.
Yeah, like a chain. Like
yeah.
There's no concept of lag there because it's fixed. It's what happened earlier. But I can do a causal analysis without trying to find any. There's no system to find any timings there. But someone could do.
But something like asking whether any tendency of like, given what you see at night, whether you could predict it with what you see in the morning or vice versa.
Yeah, how interconnected in a causal way are throughout the day.
Yeah.
Some maybe
like which times of the day are predictive of which times of the day or something.
Yeah, something like this, like forecasting.
Yeah.
Forecasting the day.
Yeah.
The day.
So I actually have a triad, Liz. I don't know if that's going to complicate things.
No.
Yeah, okay, good.
You do a pairwise.
Pairwise.
Pairwise, and then you have the matrix of your 1, 2, 1, 3, 2, 3.
Okay, cool.
So I think we're all set. So I think that so first of all, did you take the evaluation? Good. So I have that now because otherwise I always forget in my classes, and then it's like, oh, only a few people do. So okay, so that's good. So second is the rest of the hour, I'd rather you work on your cropping and all of that. And then we need to come to an agreement. I know you're busy with your finals and so on. Pretty much everyone's gonna have an A in this class. I don't want that to discourage you from doing the work, because this is actually very illuminating and it's going to be a very good methodology for you to use in your own research. So I don't want you to, just because I think that we learn a lot in class and that I got good participation and we got very good rapport and we're all very enthused about the paper. And so I think that you all deserve an A because of that. But I don't want this to discourage you from actually doing the work, because then you can actually get a paper out of this, and a really good one. We can make a really, really good one. So I know classes end, like Richard told me, December 10th. Obviously we don't have a final. Our final is this paper that we're going to create. And so I want people to be committed. Otherwise it's like we lose the momentum. So how do you propose we do this? Like next week, I want to show you the network analysis and put the code up this, and the rest of the week, I'm going to put the code up in Box, and then we can do the network analysis, revisit that together. Because some of you are going to be doing that, whether it's dyad or triad or group. This is also good for a social group. So I'll bring the example of Mona, G, and I, which is a triad, and then I'll bring the example, also revisit the example of the 10 people in my lab doing a Zoom. So we can learn about network analysis dyadically and then in a group, in a social group. But then after that, it's like, I think we should meet to discuss our progress on the paper. We shouldn't just lose the momentum, right? So I like to hear your opinion on this. And talking about agency, you're in control. So this could be both the good news and the bad news. But if you take advantage of it, it's going to be all good news, because then you know.
So is this like you're suggesting we get together later in December, or that we maybe try to have a meeting sometime in January?
No, I'm suggesting that we continue to meet on Thursdays as we're meeting for the class, but now it's going to be my last lecture is going to be next week, but me lecturing.
Mhm.
But then it should be you lecturing on the progress of your project. To that end, you can work with me also offline so that you prepare your presentation and that would be like your real, the real final is going to be the paper, but in working towards that, I think you should present what you've done. So next week I'll lecture and we'll have a little bit of an update general, but the following week, present what you've done, like whatever it is that you've done, present it. And then
like a PowerPoint where we
like a PowerPoint,
show results.
What you did and what you've done up to then, what results and what questions you have.
Okay.
And then we'll be in pretty good shape to start thinking about other analysis for the paper. And at some point, what's going to happen before the semester ends is we should distribute a template for like a paper, and we should all pitch in, like methods. So for example, Joe spent quite a bit of time doing the open pose initial analysis that does the data extraction. Nipun is going to tell us a little bit about, I don't know, whatever, or the labeling, whatever you want. The whole method section, I can write a lot of the micro movement and gamma stuff because we have that published in other papers, so it's easy to. Also the network analysis, all of that has been published. And then from there on, is each person has a set of methods, right? Because each one of you has a little sub-project that you need to describe. So you'll be describing in the template that I will send out, you'll be describing that. I'll put the template on the box too. And so we'll have, all the 9 templates or 8, whatever, however many people are there, or 10, and then we'll merge it. So methods would be the basic analytical pipeline, data acquisition with Joe, analytical pipeline with our things, and then the methods of the assay that each one of you run, and with motivation and so forth. And then we describe the results. And then we discuss, that's the fun part, where we can go with these, and caveats and things that we can improve, and then where we're going to put the code so people take it and use it and so forth. And then you have to collectively decide what journal you want to target. I don't know. I think it's a good exercise, and then we do it.
That sounds good, yeah. I can do more research on facial muscles that can sort of help us.
Yeah, we should find out. I'll send this paper on the innervation review, but we should also find out some more about muscles. For example, Dimitri Metaxas in our computer science department does a lot of, he pioneered these things, by the way. He's one of the true pioneers of extracting digitizing the facial micro expressions and so forth. He studies deception a lot. So we could go in that literature. And then there is the classical Paul Ekman literature, we should become familiar with. So to write the paper, we need to gather some literature to discuss in the intro and in the discussion. So
yeah, I can work on that too.
Yeah, so each one of you try to get a paper of 2 that relates to your own project as well.
Yeah, something about the circadian, perhaps.
I'll send videos to whom for the processing?
Huh?
Whom should I send the videos for processing? Like,
Hold on, I can't hear you. Let me up this. What is it?
can you hear me now?
Yeah.
Okay. I was asking who would be processing the videos that I would be sending?
I can process them. Just put them in the box, crop and everything, and I can process in the background and then send you an email where I basically will create a folder in your folder that says Matlab Files,
Okay.
and they'll be there. And I'll just send you an email like, hey, Nippon, they're processed. Okay, guys, any questions? No? So we're good. So I'll stay with Kaylee afterwards. Anybody else was going to talk to me after class? No. Okay. All right. So have a good afternoon. Don't lose the momentum. This is really going to be a very cool paper. And it's going to serve you for later for your what you do. All right. I'll see you next week then.
Bye.
Or email me if you need anything.
Hi, everyone.
Okay.
Hi, how are you?
Hi, good.
Good. So I just had a quick question since you mostly answered my questions in the email. So since obviously we're working on this final project all together, I just wanted to know what I could do to contribute, because I feel like on the statistical end, I'm like not as experienced and kind of lacking, and I can't even have the software on my computer, unfortunately.
So now don't worry about it. So the first thing is I'll process. Now, do you have MATLAB?
I have MATLAB, yeah.
Okay, good. So I'll process the videos, but that's like the easiest thing, because that doesn't like that's no, I mean, eventually it would be good that you have it, because for your own research it's going to be really good. Like you can get the pupils, you can get the eyes,
yeah,
the mouth. So basically it's going to be really good for you to know how to process that. But for the time being, that's just the data acquisition part. I did that, so you don't have to worry about that. The second layer is the analysis. So what the data acquisition does is acquires the open post and then converts it to MATLAB, which Joe did for us. Mm-hmm. Now we have the MATLAB files, and we have the scripts. So one thing you can start by doing is in your folder, play with the scripts that I put there, right? To create those graphs. So begin by becoming acquainted with that. Because what we're gonna do with your data is essentially pretty much that. So I'll put together a script with your data and J-Wade data as an example. So I'll analyze those, like say sad Chinese or happy Chinese. And then you can use that to run all the other stuff, because it's similar. You just need to change the name of the file, of the MATLAB file .mat. And then we discuss the result that we get. Mm-hmm. Like, also the next week or so, so the next week I'm going to talk about the network analysis, which applies also to your project, and how to use the sound and all of that. Like I started to show how to, so people should download the MIR toolbox also in MATLAB to be able to run these functions. So I'll get that done, and then I'll do one example from your project, share it with you and J-Wade. We can go over it in detail. And then you can run it with the other data. I had to recreate the data because we found that bug today. So I'll recreate it and then re-upload it. But yeah, basically your contribution also will be finding literature that is related to your project.
Yeah.
Finding literature that is related to like the neuroscience, like anatomical and neurophysiology. And basically, this would be like the foundation for further work. So this is like a pet project to get proof of concept that you could do this. And then you can enlarge this to a bigger project where you can remotely. You were asking me about participants, so people don't want to be exposed. So this is one way you can do remote research, because all you need from people is a camera facing their face, doing whatever you ask them to do.
Yeah. Yeah, that's so true. Now more than ever. Yeah.
Yeah, and that's going to be part of the rationale of this paper, that we're all in behavioral sciences where physical contact is now not possible. So it's like a way to have continuity in our science.
Definitely. It's really important.
Yeah.
Yeah, because we don't want to endanger the participants or ourselves, right?
Yeah, so this is an easy way to learn about all these things.
Okay, great. So that sounds good. So yeah, I guess just stay posted for the new things that you're gonna upload, and then we'll keep on working on it. So also, like, this is kind of a different note, but just kind of thinking ahead. So this is my first semester at Rutgers, but I wanted to apply for the cognition science certificate. Cognitive science certificate. I know there's like kind of several steps. You have to first take like pro seminar, which I'm in as well, and declare it. But just looking at the actual requirements, one of the requirements is independent study. So it would be independent study with someone who's not in my program, and kind of doing research that could be related to my research, but not exactly specifically within my field. So I was wondering if that would be like an option to continue like working, especially like on this project with your lab, or just independently.
Yeah, we can take this project that you started in the class and take it a step further. Recruit autistics or other people, adults or children, and we can expand it. So definitely, yes, we can do that. So take this project as like this pet project that you can.
Right. Yeah. No, it sounds great.
Yeah, and you can involve your advisor, tell him about this project that you're beginning to do, and if he has for the future involvement, if he has suggestions, or that would contribute, because I mean, it's not my field per se, and so the problem domain, I mean, the specific problems that you may have, given his experience, might be enriched by his suggestions and so on. So if you want to tell him also for that, to that end. Yeah. So okay.
Sounds great. Okay, well, thank you. Yeah, and I guess I'll see you next week.
Yeah, we'll see each other next week. I'm gonna redo this processing so that we got the proper, and then we can actually look at the pupils individually. And like right now the code is just the 3 regions, V1, V2, V3, but we can unfold it. Since we now know like what the pupils are, we can, for example, track the pupils, track the mouth specifically, so track the eye specifically, so we can do various refinements of the code. Yeah.
Okay, great. Yeah, I'm excited.
Okay, Kaylee, sounds good. See you
Thank you
next
so
week.
much. Okay, see you.
Bye.
Bye.